Alright everyone, welcome back to Geotech Master. It's been a fantastic journey through our series on geotechnical investigations, master planning for site characterization. We're thrilled to provide you with a recap of everything we've explored together. Throughout this course, we've systematically built our understanding of how to strategically plan and execute those crucial initial steps in any geotechnical engineering project. Our aim was to move beyond just the basics and truly master the art of site characterization.
Let's take a quick walk through the sessions and revisit the key takeaways. In Episode 1, Introduction to Developing a Subsurface Investigation Plan, we laid the groundwork by discussing the essential steps for creating a robust investigation plan, the factors that influence its scope, and how to ensure relevant data collection to minimize uncertainties. Moving on to Episode 2, Developing a Geophysical Testing Plan. We explored how to use non-invasive geophysical methods to get a broad subsurface overview, understand stratigraphy, and pinpoint potential anomalies, allowing us to optimize subsequent investigation efforts. Then, in Episode 3, Introduction to Selecting Locations for Subsurface Investigations. We discussed the key considerations for deciding on the number and locations for in-situ tests, drilling, and sampling, emphasizing the influence of project objectives, features, subsurface conditions, anticipated uncertainty, and access constraints. In Episode 4, Introduction to Minimum Depths for Subsurface Investigations, we tackled the crucial question of how deep we should investigate, exploring guidelines and rules of thumb based on project features like shallow and deep foundations, and the importance of considering subsurface stratigraphy and soft compressible layers. Continuing with location considerations in Episode 5, Factors Influencing Geotechnical Investigation Locations. We discussed additional factors beyond the number and initial depth, such as soil and rock type, underground utilities, anticipated ground variability, and site accessibility, and how geophysical testing can help optimize these locations. Next, in Episode 6, Determining Types of Samples and Sampling Frequency, we distinguished between disturbed and undisturbed samples, explained their uses for index and performance tests respectively, and explored the factors influencing sampling frequency, including subsurface variability and project type, along with some recommendations. In Episode 7, Introduction to Subsurface Investigation Planning, we stepped back to look at the fundamental reasons why subsurface investigations are necessary, highlighting their role in ensuring structural stability and safety, and provided an overview of the overall planning process, including defining objectives and selecting appropriate testing methods. We then talked about the practicalities of testing in Episode 8, In Situ Testing, what, why and how, discussing the main objectives, advantages, like minimal disturbance and in-situ stress measurement, and disadvantages, like indirect measurements and empirical correlations, of in-situ tests, and how to choose the right test for the job. With an introduction to common tests like SPT and CPTU, expanding on in-situ methods, Episode 9, Rock Field Tests, Direct Shear, Dilatometer, and more, focused on specific in-situ tests used for characterizing rock masses, emphasizing the importance of field mapping and evaluating rock discontinuities to understand the strength of the rock mass, not just the intact rock. We then dedicated an entire session, Episode 10, Introduction to Piscicone Testing, CPTU, to this powerful in-situ test, highlighting its importance in stratigraphy development, groundwater assessment, determining subsurface uniformity, and guiding the planning of subsequent sampling and testing, following our exploration of testing. Episode 11, Geotechnical Sampling Strategies, What, Why, and How Often, provided a deeper dive into the importance of representative samples, the differences between disturbed and undisturbed samples and their respective sampling methods, and how soil and rock variability and in-situ test results guide our sampling frequency. In Episode 12, Introduction to Geotechnical Investigation Borehole Methods, We discussed various techniques used to create boreholes, such as solid flight auger, hollow stem auger, rotary drilling, test pits, and exploratory shafts, and how to choose the appropriate method based on soil type, site conditions, and integration with sampling and testing efforts. Transitioning to the laboratory, Episode 13. Introduction to laboratory testing, differentiated between index and performance tests. Explained how to select the right lab tests based on project needs and soil rock types, and touched upon the importance of reviewing in situ results and sample classifications to determine the necessary quantities of tests. Finally, our last session, Episode 14, Introduction to Groundwater, addressed the critical role of groundwater in geotechnical analysis and design, and the essential parameters we need to evaluate for a comprehensive hydrogeological characterization, including geology, aquifer-aquitard characteristics, groundwater levels, and flow direction and gradient. Now, as you know, this in-depth series on Geotechnical Investigations, Master Planning for Site Characterization, was specifically designed to build upon the fundamental knowledge presented in our earlier course, Geotechnical Investigation Essentials. This previous course provided the bedrock understanding of geotechnical engineering principles. In that foundational series, we explored crucial concepts such as geotechnical engineering basics, essential site reconnaissance techniques, various subsurface exploration methods, the principles of geotechnical data analysis, and the fundamentals of soil and rock classification. We also established the goals of geotechnical investigations, including assessing site suitability and enabling economic design, and highlighted the critical role of subsurface investigations in revealing Earth's secrets. Understanding these core ideas from the previous course will significantly enhance your appreciation and mastery of the strategic planning we've covered in this series. If you haven't yet had the opportunity to complete the Geotechnical Investigation Essentials course, I strongly encourage you to do so. You can find a link to that course in the description below. It will provide you with the necessary foundation to truly grasp and apply the concepts we've discussed in this series. And the learning doesn't stop here. We are continuously developing new and exciting content to help you advance your knowledge in geotechnical engineering. So, stay tuned for our future courses and videos, where we'll explore even more advanced topics and practical applications. Thank you once again for being an engaged member of the Geotech Master community. We sincerely hope this series has provided you with valuable insights and practical knowledge that you can confidently apply to your geotechnical projects. Keep exploring, keep learning, and we look forward to seeing you in our future courses.